Okay, so basically, I'm on leave at the moment, and in the next 2 months, I don't think I will get other times available to record this video, so I'd rather leave the specialist math exam 2 for now. So let's have a look at this paper. Just a few things to note. One, this paper, even though it's a great resource for the November exam preparation, it was still following the 2016 to 2022 study design, which means some questions, some parts are irrelevant to the current study design, like the mechanics, forces, whatsoever. Two, we will still need to look at proof questions, lines, planes, vector equations, and so on. And also some new stuff like integration by parts, recursive relations. These things are very important. So don't forget to revise for the new contents. And lastly, pseudocode, okay? Right, so let's have a look at the question 1. The implied domain and range of f of x equals to sine cosine inverse 1 minus 2x. Okay, so I think I will plot this graph accordingly. Right, so make sure your cast is on the radian mode. So basically, I'll just type out sine bracket arc cos. And the other thing is 1 minus 2x. Okay, so it looks like this is a semi-ellipse. So the domain from 0 to 1 and the range is 0 to 1. Therefore, I will choose option A, okay? So let's have a look at the next one. Next one is another composite function. Another composite function, so we put a linear function g of x into f of x, which is arc sine x. Notice that this is a decreasing arc sine, so it might have some reflections involved. Let's have a look. So basically, the question provided you 5 options, and I think I should eliminate the positive options, okay? Because sine inverse looks like this, okay? If I don't have any negative numbers in front of x or y, but now we are looking at this decreasing sine inverse graph. So I believe the center is like 1, 0. So probably I'm looking at sine inverse half x, actually half minus half x, maybe. That means my a value could be half and a b value could be half, minus half and half. So let's have a look at the graph. Let's try to make this one new graphs. Arc sine half minus half x. Okay, looks perfect. So it looks like half minus half x. Well, you may want to substitute the endpoints to verify if they have the correct y values. So now I'm looking at f2 of x. Let's press Control Doc. f2 of curly bracket minus 1, 4. Whoa, non-real result. That's an interesting one. Actually, minus 1, 3. Well, half pi and minus half pi, so perfect. Option C will be correct. Okay, moving on. The graph of the relation f of x equals to absolute x minus 1 divided by x squared minus 1 does not have something. So the domain is from is all real numbers, excluding minus 1 to 1, horizontal asymptote, vertical asymptote. Well, I believe they have the vertical asymptote because you can see apparently, even though you can cancel out x minus 1 something, Still expecting some sort of a plus or minus 1. Maybe some point of discontinuity, vertical axis intercept, so x can take 0. That's also true. Horizontal asymptote, well, a linear divided by a quadratic, well, horizontal asymptote could be y equals to 0. So I probably will look at option E. If it really has a local maximum turning point, well, let's see. Okay, so I'm looking at absolute value x minus 1 divided by x squared minus 1. Okay, now, the interesting thing is this bit. This bit is like a hollow point at x equals to 1. It's definitely not a turning point or local maximum because you can see it has some sort of feature like a reflecting this part around. So option E should be our intended answer. Okay, that's E. All right. If z equals to a plus bi, a, b are real numbers, and a greater than b greater than 0, then argument z plus I z bar. Okay, so z plus I z bar. Basically, this is a plus bi plus I times a minus bi. So you should get a plus bi plus ia minus bi squared. So you should have a plus bi plus ai. Well, minus I squared is minus 1. So minus 1 times 1 plus. Let's put this complex expression in a nicer way. A plus b plus a plus bi. Well, if you just draw a little diagram, this is a plus b, this is a plus b. So basically, this is referring to a complex number here, okay? So the angle, because the two sides of the triangle are equal to each other, pi over 4, okay? It can only be option D, okay? It is impossible to get minus 3 pi over 4 because it's in the first quadrant. Question 5. Oh, typical problem, complex conjugate root theorem. So if you look at the polynomial they gave to you, all coefficients are real numbers, and this condition confirmed that. So with this root, I should be expecting z equals to 2 plus 4i and a z equals to 2 minus 4i, okay? And then you could do some sort of a z minus 2 minus 4i bracket, z minus 2 plus 4i to get a quadratic factor. Remember, you have to use your z, the letter, subtracting the complex numbers, and then multiply the factors together. And then you should get z minus 2 squared minus 4i squared. So z squared minus 4 plus 4 plus 16. Okay, something like that. But to be honest with you, I'd rather using CAS calculator to deal with this situation. So let's have a look. Okay, so what I'm trying to do is I would define a polynomial. P of z is a sign. A sign button is control template button, okay? Z to the power 3 plus P times Z squared plus Q times Z plus 5. And then we could substitute the given solution, P of 2 plus 4i equals to 0, P, actually, I've got a little bit problem here because you see, if I define my polynomial like P of Z, here is a contradiction, okay? So I can't do that. So probably I need to delete the variable P, okay? Instead of using P as my function name, I would use F, maybe. Delete that, delete that. Okay, now, instead of solving P something equals to 0, I'm using F something equals to 0. F when Z equals to 2 plus 4i equals to 0, P, Q. Right, so basically I should get the p-value is minus 15/4 and q equals to 19. Now, let's put the p and the q values back. Minus 15/4 plus 19. And then let's try to solve f of z equals to 0, because the question only looks for the real root, which is -1/4. So this is option B, okay, boy. Now, just reminder, you could also use C-solve. C-solve button means complex solve, okay? This is quite useful in specialist math. See, 2 plus 4i to minus 4i is equals to -1/4, the real root, and a pair of complex conjugate roots. So let's have a look at the next one. Fantastic. The set S consists of all points on a complex plane that are equidistant from the point, represented by a 1 plus 2i and -2 plus I. So we'd like to find, okay, this is a perpendicular bisector. So drawing the diagram. So this is the real axis. This is the imaginary axis. 1 plus 2i is here, 1, 2. -2 plus I is here, okay? -2, 1. Now, because this is a perpendicular bisector, we're actually expecting some sort of a graph like that. Well, if you draw the diagram accurately enough, you could see, okay, this is a straight line with negative slope going through the origin, okay? So option E is our best bet. Just want you to notice another possible approach. You could also write this equation as z minus 1 plus 2i bracket, absolute value z minus -2 plus I, absolute value, and then chucking in z equals to x plus yi, okay? And then find the Cartesian equation in terms of x and y only. So basically, that is solving this equation on your CAS calculator. Let's have a look. So let's do absolute value x plus yi minus 1 plus 2i equals to another absolute value x plus yi, and it's subtracting -2 plus I. Just notice the I must be accessed from the pi button, okay? On my computer, I just typed out the @I to represent the imaginary unit I. Okay, let's see how we go. Okay, so we have an equation involving x and y only. Now we can solve answer, y. Excellent, y equals to -3x, correct. So let's have a look at the question 7. Question 7 looks like an integral question. The definite integral can be expressed. Okay, this is a typical U substitution question. Notice that you have an odd power here and an even power here with sine and cosine term. If you set one to be U, the other must be du dx or negative du dx, okay? So I will rewrite this one as 0 to half pi. Let's write cosine x, split out 1 cosine x times cosine squared x times sine squared x dx, okay? And the next job, you want the higher power terms to be consistent in one category. So you should write 0 to half pi cosine x, writing cosine squared as 1 minus sine squared x multiplied by sine squared x dx, okay? And then you should be writing 0 to half pi cosine x sine squared minus sine to the power 4 dx. So apparently u is sine x. So du dx will be cosine x, which is here. So when this thing is multiplied with dx, later on you use the reverse chain rule to get du. And notice the old terminals are 0 to half pi. So you should get x equals to 0, sine 0 is 0. X equals to half pi, sine half pi is 1. Okay, special values, very easy. 0 to 1. So these two numbers are your u variables, okay? U squared minus u to the power 4, du, okay? Comes from cosine x times sine x. If you take a closer look at the available options, I believe u squared minus u4, okay, option C. All right? So that's the first 7 multi-choice questions. You shouldn't spend very long time for each multi-choice question. Okay, question 8. The direction field shown above best represents the differential equation. Well, I believe I will just use my task calculator to test the first and the last option. See which one will match the provided slope field. Okay, so let's start with y over x first. Okay, so press Control Doc, add graphs. Now to plot the differential equation, you have to go for menu, graph entry, 8 differential equation, menu 3-8. Now notice one thing, the default letter here was y1. You don't want to use y1, delete the y here. Let's try y divided by x. And you can leave the initial condition x naught, y naught optional, leave them blank. But before you press enter, it is highly recommended to press these edit parameters and drag it down to the end. Find this category, field resolution. Normally I will change this number to 30 and press OK. Right. So does that look like the graph? Well, maybe, maybe not. Let me just type -8 here and 8 here. Well, the density is not big enough for us to determine, okay, whether or not it matches. But you can clearly see there is a pair of diagonal asymptotes or whatsoever, like y equals to x or y equals to -x. So I would say, let's change this differential equation to the last option, -y over x squared, and see how we go. Well, if you change this to minus y over x squared, doesn't quite look like the one provided. So I need to go back to double check y squared over x squared. Y squared over x squared, well, it exhibits some sort of a parabolic behavior. So option C, y squared over x. Well, option C is much better because you can see some sort of parabolic behavior, okay, like a parabola. Like you could also press tab if you wish. You could add in an optional arbitrary condition, initial condition, let's say 0, 2. Okay, if you type in 0, 2, doesn't quite give you some sort of fruitful result or apparent result. So maybe we should choose 1 and 1. Okay, try some special point. Okay, excellent. So you can see a possible curve going through 1, 1. Looks like some sort of a half parabola or, similar graph, okay? So that gives us the closest match. Based on option C, we plotted the differential equation, the slope field, and we add in 1 extra point to confirm the accuracy of one particular solution. So I believe option C is the best choice, okay? All right. Option C. Well, you could also physically draw a plot point. Let's say this is 1, this is 1. And you can see if you try to draw some sort of a graph, make sure your curve does not cross with the slopes. But you can see, okay, quite good, quite good. Okay, question 9. Length of a curve from 1 to 5. Okay, it's given by this integral, but in functional form. So I think the integral should be this curve. Let's call this curve y equals to f of x, okay? Under the square root, you are expecting f dash of x squared. So f dash of x is this guy. F dash of x squared is 1 over 4x to the power 4, which is 1 over 2x squared whole thing squared. So basically, I could have f dash of x equals to plus or minus 1 over 2x squared, okay? Just be aware of the plus or minus when you take a square root algebraically. Now, you want to find the equation of the curve. So I think you will try to use your differential equation solver. So like DE solve y dash equals to 1 over 2x squared, comma x, comma y. So this is one possibility, y equals to integration constant c minus 1 over 2x. Alternatively, you could get positive, I suppose, because you can put this y as negative 1 over 2x squared. So it could be 1 over 2x plus another integration constant c. Therefore, I believe there's only one option available, minus 1 over 2x, with a c value chosen to be 0, okay? Option D, dog. Some of you may wonder why I use D solve, because well, this is one-step integration. So for example, you get a f of x equals to 1 over 2x squared dx. This is like half x minus 2 dx, okay? Or you could put this one as minus, then this one will be minus accordingly. Then it's just a matter of choosing the available options, okay? All right. An inverted right circular cone of radius 1 meter and a height 2 meters is initially full of water, as shown below. Well, typical related rate problem, we can use a similar triangle. Just remember, at any time t, the radius and height will change if the water is leaking out from the bottom of this cone. But yep, water flows out through the hole at the bottom at a rate of 0.5 root h meter cube per hour, where h is the depth of water remaining in the cone after t hours. At the time t hours, the h dt is given by something. So I expect the h dv multiplied by dv dt, okay? Chain rule. That's why we use related rates. But before that, we need to see v is a cone 1/3 pi r squared times h. But we don't want a two-variable function. We need a one-variable function. So r over h, the ratio between r and h will remain the same as long as the edges, the slant edges are straight lines, okay? So you should get 1 over 2, okay? 1 divided by 2. So r equals to half h. Therefore, v equals to 1/3 pi times h over 2 squared times h, which means you will get pi h to the power 3. 4 times 3 is 12. So dv dh is going to be pi h squared over 4, because the 3 cancels out the 12 to be 4, okay? Right, so dh dv is going to be 4 over pi h squared times, remember, this is a negative rate, flows out, so dv dt is negative 0.5 divided by, oh, actually, times root h. Bear with me. Okay, now, because you can simplify the top as minus 2 root h divided by pi h squared. And notice root h is simply h to the power of 0.5, h power half. So you should have -2 over pi h 1.5 here, okay? Just divide them through, okay? And you are using 2 subtracting 1/2 index law. So the answer is option E, okay? I believe many would get bogged down with option D, but don't forget, water flows out, leaks out, drops, etc. These sort of phrases means negative rate of change. Okay, another interesting question. The position of a moving particle at time t is given by this position vector here. Immediately after I see this position vector, I'm thinking about x equals to 5 plus 2 cosine of t, y equals to 3 lots of 1 plus sine t. And the question provided a domain for t, the parameter or time. The graph that shows the path and the direction taken by the moving particle. Well, I think there are 2 possible ways, at least. One, you could chuck in the 2 t values into both x and y and determine, okay, where is the start point, where is the end point. Another possible way, if you are very technologically savvy, you can go for your CAS calculator, just press Control Doc, add graphs. But remember now, we are not plotting a function, we are plotting a pair of parametric equations. So graph entry, parametric. Well, just notice, once we put 5 plus 2 cosine t and 3 plus 3 sine t, you need to change the t domain from pi over 2 to, let's say, 3 pi over 2. And I highly recommend you to change the t step to 0.03. Well, you can see here is the trajectory of this moving particle. And you could also press menu, trace, and then press graph trace. Now, see, this is the beginning t value. You can now press right. Okay, looks like the direction of motion along the path, the particle is traveling downwards, okay, from top to the bottom, okay? And it's the left half of this ellipse. Therefore, you should choose option E, okay? Only option E gives you the correct shape and correct direction. Just don't forget to change the t domain, all right? And adjust your t step. Okay. Question 12. The position of a particle at a time t seconds is given by this thing here, where displacement components are measured in meters. The maximum speed of the particle in meters per second. Before you get the speed, you should differentiate the position vector to get velocity first. Once you get the velocity vector, you can now find the speed expression. The magnitude of Vt is square root of 9 cosine squared 3t plus 36 sine squared 3t, okay? So now we are trying to find the maximum value of this whole expression. Notice that you can split out from the larger number if you have sine squared and cosine squared with the same angle 3t. We can split out a 9 sine squared, okay? So the inner part can be written as 9 cosine squared plus 9 sine squared. What's left is like 27 sine squared 3t, okay? Under the square root. So all in all, you should have 9 plus 27 sine squared 3t. Now the only variational part is the sine squared term. Remember, sine function, cosine function, they are bounded between -1 and 1. Once you square it, it will only go from 0 to 1. So sine squared 3t can take a maximum value of 1. Therefore, the speed max is going to be 9 plus 27, which is root 36, and it's 6. Option C is the maximum speed. Okay, now question 13 is a little bit interesting because it tells you the vector resolute of A in the direction of B is this thing, okay? So A parallel is going to be 2I minus J minus 2K. And also, A itself is 4I plus 3DJ minus DK. So we want to find the value of D. Now, if we have no clue at all, simply because they don't provide you the vector B, then we can think of other sort of strategies to cope with that, because we have an implied information, this perpendicular vector, okay? So this perpendicular vector is A subtracting A parallel, okay? Because A parallel plus A perpendicular is A. And notice, because they are perpendicular to each other, you can use dot product equal to 0, okay? So basically I could say, all right, my perpendicular vector is 4, 3D minus D, subtracting 2 minus 1 minus 2. So eventually you should get 2. 3D minus minus 1, 3D plus 1. And then minus D plus 2. Okay? And then if you take the dot product, like A perpendicular times A parallel, it should be equal to 0. So 2 times 2, 4. Minus 1 times 3D plus 1. And then minus 2 times 2 minus D equals to 0. So you can get 4 minus 3D minus 1 minus 4 plus 2D equals to 0. And let's tidy this up a little bit. We should have, okay, 4 minus 4 canceled. Now I should have minus 3D plus 2D, that's minus D. Minus 1 equals to 0. Therefore, D equals to minus 1. See, sometimes it's just more conceptual rather than computational, okay? Of course, you could also use some sort of a brute force approach like A dot B. Actually, we could use A dot A parallel divided by A parallel times A parallel times A parallel, okay? Because A parallel has the same direction as B, that equals to A parallel, okay? Some sort of abstract computational way to figure this out, okay? All right, question 14. Question 14, the angle between the vector and the positive direction of the z-axis. Well, as long as we are looking for, here is a vector, let's call this u, x, y, z. As long as we are looking for the angle between a vector and one particular axis, we can always use unit vector. Unit vector has another special name called directional cosine. So each component represents cosine alpha. Alpha is the angle between u and x. And cosine beta, the angle between u and y. And cosine gamma, okay? That is the angle between u and z, the positive direction, okay? So if u is 1i plus 2j plus 1k, the magnitude of u is square root of 1 plus 4 plus 1, which is root 6. So u hat is going to be 1 over root 6i plus 2 over root 6j plus 1 over root 6k. Therefore, my cosine gamma, the angle gamma, is between the vector and the z-axis. that is equal to 1 over root 6. So gamma is cosine inverse 1 over root 6. Okay? Simple as that. Option D. Right. Forget about mechanics, okay? Forget about the mechanics. But for historical purposes, I'll still finish this question off. mg is the gravity of the m kilogram object. Here you have a tension. Here you also have a tension. 4g, and then reaction force, or R or N, okay? When released, the 4 kilogram mass accelerates at 1.5 meters per squared second to the right. Basically, the m kilogram drags the 4 kilogram along the table because the m kilogram is moving down. So the combined equation is mg minus t plus t minus nothing, because we don't have any frictional force here. So I just write the combined mass m plus 4 times a. A is 1.5, okay? Newton's second law, good old time. Okay, then you can just use your CAS calculator to figure it out, okay? 9.8 m equals to 1.5 m plus 6, okay? Then you solve that equation. Solving this equation, I suppose, let me have a look. .7 something, okay? 72289, etc. Option B. All right, another mechanics question. Well, but it's actually related to Suvat. So, well, if the examiners were setting up some sort of questions, they should directly tell you the acceleration, because now F equals to ma is out of the current study design, okay? Anyway, a mass of 5 kilograms sitting at rest on a smooth, okay, we don't have smooth horizontal surface, we don't have any frictional forces. Horizontal force is 10 newtons, 5g, and the reaction force R, they should cancel each other out. Now, basically, the combined force, the resultant force is equal to 10, but it's also equal to 5 times A. So acceleration is 2 meters per squared second. So this is the direction of the acceleration, to the right, or in the positive direction. Now, how far will the mass move from its original position in 3 seconds? So initially at rest, u equals to 0. We know the acceleration is 2, t is 3. So suva s equals to ut plus half at squared. Now this is 0, 0 plus half times 2 times 9. So 9 meters. After 3 seconds, the displacement relative to the start point, the original position, is 9 meters. So it has moved 9 meters. Okay, question 17. The velocity of the particle when it is x meters from a fixed point is given by root tangent inverse bracket x. If the force acting on the particle is 1.5 newtons when it is 1 meter from origin, then when the force acting is 1 newton, the distance of the particle from, okay, right. So it's also related to F equals to ma. Now, again, you are not expected to use this formula for the current study design, but one important thing you do need to know is acceleration. V equals to dv, V times dv dx equals to A, okay? Or you can say half d dx v squared. So you square the function in terms of x, velocity function in terms of x, square it to get a v squared, and then take the derivative and multiply by half, okay? Right. So what I'm trying to say is the mass itself is unknown. So I'm going to say F equals to 1.5. That is equal to m times derivative tangent inverse of x, because you squared it, okay? V squared equals to tangent inverse of x when x equals to 1, all right? So you can figure out m first. Right, if you do it by hand, it's not very hard because the derivative of tangent inverse is 1 over 1 plus x squared. When you, after the differentiation, you just chuck in your x equals to 1, and you should get m equals to 2 times 1.5 is 3, okay? And then when the force acting is 1 Newton, so F equals to 1 equals to mass is 3 kilograms times ddx, tangent inverse of x. Okay, now we don't know the particular value of x. So 1/3 equals to 1 over 1 plus x squared, okay? Differentiating that. And 1 plus x squared equals to 3, x squared equals to 2, so x equals to plus or minus root 2. But the question says the distance of the particle from O, so we take the magnitude. We want the absolute value of the particular displacement, okay? So choose option B. So again, question 15, 16, and 17, they all have small elements of mechanics, F equals to ma, but this year we should focus on more kinematics problems. Okay, right, question 18, 19, and 20, definitely relevant because we still have probability and statistics, okay? So each night, a student typically spends 100 minutes on math homework and 40 minutes reading. The standard deviation of the time spent on mathematics and reading are 12 and 5 respectively. Assuming that the time spent on the two tasks are independent and normally distributed. Okay, the probability that a student spend less than a total of 120. So let's, on both math and reading on a particular night. Okay, let's call the time we spend on mathematics m. M is normal distribution. Well, the question didn't provide us a particular phrase like a mean value. So we say 100. We have to assume 100, 12 squared. And the reading is R, normal distribution, 40, 5 squared. So the combined time is m plus R. Because they are independent of each other, we can easily get the expected value, combined expected value, adding 140, 140 minutes. The variance of t is the variance of m plus variance of reading. So 12 squared plus 5 squared. Well, fantastic. 12, 5, 13, Pythagorean triads. So this will be 13 squared. So the standard deviation will be 13. All right. My target is to get this t less than 120. So we are looking for probability t less than 120. Okay, now it's time to use our norm CDF to get the answer. Let's have a look. Norm CDF minus infinity. We're still using minus infinity as our lower bound because the domain of the normal variable goes along the x-axis, in both directions, okay? Rather than stopping at a 0. Minus infinity to 120, the combined mean is 140, and then the standard deviation is 13, okay? So we get roughly 0.06196, etc., okay? So roughly 0.06. Therefore, we choose option A, okay? All right. A random sample of 50 passengers. Okay, this is my M value, 50. Flying from Melbourne to Brisbane has a mean mass of 73 kilograms. Mean mass, well, Is that x bar or mu? I'm not entirely sure. So let's just write x bar equals to 73. And the standard deviation sigma equals to 8. Now we want to find an approximate 95% confidence interval for the mean mass. Assuming that the standard deviation obtained from the sample is a sufficiently accurate estimate. Well, what I'm saying is, what the question is saying, a standard deviation, this is actually S, the sample standard deviation. But because the question says this assumption, we can assume S equals to sigma, which is a population standard deviation, okay? Right. I don't think I need to formulate the calculation here. Just go for the CAS calculator. Menu 661 is for special, 665 is for method, all right? Well, almost always change your data input method as stats, okay? And press OK. Sigma is your 8. X bar is 73. N value 50 passengers. Sea level, because we want 95%, we don't need to change that. Press OK and press Control Enter. Well, some of your calculator will spit out the decimal approximation directly. My calculator is always on exact mode. That's why I need to press Control Enter. 70.78, 75.21 or 22, okay? So option A is the closest answer, because all the confidence intervals have their endpoints round to 1 decimal place, okay? All right, let's have a look at the last one. X and Y are independent random variables, each of which has a mean M and a variance V. Okay, right, so EX equals to EY equals to M. Variance X equals to variance Y equals to V. So the expected value, well, the question didn't ask for expected value. It's just looking for standard deviation. So let's do variance Z. Well, to be honest, I'd rather seeing this one to be W rather than Z. Anyway, doesn't matter. Variance Z equals to variance PX plus QY. So now this is the linear transformation and a linear combination. So we can take out the P squared rather than P loss of X. Plus, take out the Q, square it, variance Y, okay? P squared times variance X, V, plus Q squared times variance Y, which is also V. So now if we take the standard deviation, we need to take the positive square root. So P squared times V plus Q squared times V under the square root. And inside the square root, we can simplify by taking out the common factor V. Therefore, my answer is option B, okay? Lovely, lovely 20 multi-choice questions. So let's have a look at the rest. 6 extended response questions. So let f of x be 4x squared plus 2x plus 7 divided by 2x squared minus 3x minus 2. First part, express the function f of x in proper fraction form. Second part, state the equations of the asymptotes. Well, straight line asymptotes, I suppose. And part C is sketching the graph. Okay, now I probably want to go through the CAS calculator approaches, but that would be rather time consuming. So you can use prop frac and put this f of x in, okay? Before you do that, you should define f of x. So basically, f of x is just 2 plus 8x plus 11 divided by 2x squared minus 3x minus 2, okay? Well, you shouldn't express this one in partial fraction form because you know this one can be further decomposed into two parts, okay? So just leave it like that. Now, state the equations of the asymptote of the graph of f. When x is going to be very large or negative infinity, your f of x will approach to 2, okay? So don't overlook that. So there is a horizontal asymptote at y equals to 2. And also, your denominator should not be equal to 0. So when it is equated to 0, that gives you, for example, x equals to -12 and x equals to 2. So these are two vertical asymptotes, okay? Totally, you have 3 asymptotes. So don't forget there is a horizontal one, okay? And for part 3, part C, you can use the previous result like, okay, you obtained 3 asymptotes. Now, just draw the asymptotes with your ruler, okay? Okay, so that is one vertical asymptote. And another vertical asymptote is at x equals to 2. So make sure you accurately plot them and label them, okay, with the equations. And also don't forget you have a horizontal asymptote. And label this equation, y equals to 2, okay? Now you can use your CAS calculator to locate all the important points, stationary points, inflection points, coordinates correct to 2 decimal places, okay? And any intersect with the coordinate axis. So basically, from my calculator, I obtained, for example, when x equals to 0, the y-intercept is minus 3.5, okay? Or if you wish, you can label this one as a fraction, okay? But minus 3.5 or minus 7/2 doesn't make much difference. But make sure you also locate another stationary point. This is 0.34, comma, minus 2.92. So make sure your point is in the correct grid, okay? In the correct box. And the middle branch is not symmetrical, okay? It's slightly towards the left. Okay, and also you can gauge 2 accuracy points, like this one, and also, let's say, here. The right outer branch is slightly a bit further away from the 2 asymptotes, okay? Don't draw them too close to the asymptotes. Make sure you consult with your CAS calculator screen carefully, okay? And show some good asymptotic behavior. And finally, the left branch. Be aware of the locations of the points, okay? For example, you should be expecting a point of inflection at a minus 4.90, 2 decimal places. 1.54, and the other stationary points is slightly lower. I know it's a bit hard, but try to draw as accurate as possible. This is minus 3.09, comma, and 1.48, okay? This is a local minimum. Also pay attention to where the graph crosses the horizontal asymptote, okay? Roughly here. Like I actually figured out this is minus 1.375, 2, but this point is not required by the question. Finally, double check if the question provided you a domain restriction. In this case, the question didn't say from -6 to 6, so you should have your graph asymptotic or getting closer and closer to, let's say, the horizontal asymptote, like in this way, okay? And then draw very carefully for the last bit of the asymptotic behavior, okay? Doesn't matter if you don't draw the arrow here, but This is just my personal habit, okay? You can draw arrow here indicating the way the graph approaches to the particular asymptote. But make sure your graph is not swirling away like this, like that, or even running parallel to the asymptotes. Okay, so basically that's a 3 marks graph question. Now, let GK of X be, okay, basically very similar function, but then we want to find this value such that the graph only has one vertical asymptote or no vertical asymptote at all. So basically, if we are analyzing the vertical asymptote, before we do that, notice that this is a quadratic divided by quadratic. We should always check, do they have same factor? If they have the same factor from the bottom and the top, they will cancel out and form some sort of a point of discontinuity. So that's another point to note. But if we quickly look at the top, the discriminant is 2 squared 4 minus 4 times 8, which is 4 times 7. Fantastic. This is, let's say, a negative number. So not factorizable. Therefore, we don't need to worry about the particular case, the intricate case, where we can find some sort of cancelable factors, okay? No cancelable factor, good. So we can proceed to analyze the discriminant. Delta equals to minus 3 squared minus 4 times 2 times k, which is 9 minus 8k. If it only has one vertical asymptote, the discriminant will be 0. Therefore, my k value will be 9 over 8, okay? If it has no vertical asymptote, I expect my delta 9 minus 8k to be less than 0. So 8k is actually greater than 9. So k is greater than 9 over 8. Notice that the question says the values of k. So just be aware of the phrasing. For some parts, you may want to express your answer as an inequality or interval notation, okay? All right, the graph of G2 is rotated about the x-axis from 0 to 5 to form a solid of revolution. Good point, solid of revolution. I can just write down a definite integral that gives the volume. Evaluation of this is not required. So we just write v equals to pi from 0 to 5. G2 of x bracket squared dx. The question didn't specify whether or not we should write it as, explicit form, but it's always good to have an explicit form, the correct explicit form in front of us. Okay, don't forget to square everything, dx. Don't forget your pi with dx, okay? Because that's a simple mark here. You don't want to lose that simple mark for any sort of mistakes. All right, so it's a fairly easy question 1, and let's have a look at question 2. The circle given by z, absolute z plus 2 minus I root 3 equals to 2 root 3 has its center minus 2 root 3. Verify by substitution that z equals to minus 5 is a real axis intercept of this graph and find the other real axis intercepts. So what I'm trying to do is verify first. If z equals to minus 5, the equation has left-hand side equals to minus 5 plus 2 minus I root 3. Absolute value equals to absolute value of negative 3 minus I root 3. So we are finding the magnitude of this complex number, minus 3 minus I root 3. Basically, you just need to say, okay, this is a square root of negative 3 squared plus negative root 3 bracket square. don't bring in the I and square it, okay? We just need the imaginary part without the I when we square it in the Pythagoras working. So we have 9 plus 3, which is root 12, and that is equal to 2 root 3. Excellent. It's equal to the right-hand side, so it's verified. Okay, now, another thing I want you to notice is it is very common for us to figure out the Cartesian equation first. Like, for example, you could write it as x plus 2 bracket square plus y minus root 3 bracket square equals to 2 root 3. Well, in this form, you need to square it because this is a radius, 2 root 3. And then we chuck in y equals to 0 to find the x value. But your CAS calculator, especially for TI Nspire, is very powerful. What I want to show you is press Control I, add a calculator. Now, you could actually go for menu 371 first, and then just change the variable to Z, okay? After you've got the solve template with a single variable Z here, go back to the front and just type a C here, and then type out the absolute value template, and then fill in the blank, Z plus 2 minus I square root of 3 equals to 2 root 3. So that equation itself is one constraint. The other constraint is if you want the, real axis-intercept, what can be 0? The imaginary part of this variable z is 0, like y equals to 0. Press enter, you will get -5 or 1. So the other real axis-intercept is simply 1 or 1 plus 0i, okay? In a similar fashion, you could also copy the whole line down and find the imaginary axis-intercept. Say you change this image to REAL. So you should get 2 purely imaginary numbers along the imaginary axis to locate the approximate locations. You could press Control Enter. It's roughly 4.56i or minus 1.096i, okay? Something like that. Okay, so let me just get back to the working document and complete working hours. Of course, you can write this thing as 1, 0 because the question didn't specify, okay, in Cartesian form or as coordinate pairs, but well, either form should be fine. And then just accurately locate the center first, okay? The center. Notice that the root 3 is 1.7 something, okay? So -2 root 3. This is the center. The graph, the circle goes through -5, 0, and 1, 0, okay? And also from the previous calculator work, I actually found the 2 intercepts, okay? That is 0, root 3 take away 2 root 2, okay? And 4.56 something, roughly here, okay? 0, root 3 plus 2 root 2. You should label them as exact values, okay? The question didn't say round them to certain decimal places. See, label the axis-intercept with their values, okay? With their values, or you can write it as z equals to root 3 plus 2 root 2 bracket I. Either form, okay? Or root 3 minus 2 root 2 I, etc. Okay? But you can't mix them. A common mistake for students from the student is like writing an extra I here, which doesn't make no sense, because along this axis, we're just looking for the constant here rather than putting a constant multiplied by I. Okay, now it would be nice if you bring in a pair of compasses, okay? Draw a accurate circle. All right, so basically that is the circle required. Let's label this one. Z plus 2 minus I root 3 equals to 2 root 3, okay? All right. The line given by Z plus 2 minus I root 3 equals to Z minus Z naught is tangent to the circle given by that at Z equals to minus 5. Find Z naught in the form A plus IB, where A and B are real numbers. So the tangent at this point, well, it is not harmful for us to draw a physical tangent here, okay? Doesn't matter. But then we should realize a tangent to the circle must be perpendicular to its radius, okay? Must be perpendicular to its radius, which means, okay, looking at the form of this equation, one reference point is actually the center of the circle. Another reference point, Z0, should be equidistant to the blue line, blue tangent we just drawn, okay? So notice this feature. You notice this is root 3. From minus 5 to minus 2, this is 3. So we can actually go back by 3 units to the left, okay? And then go down by extra root 3 units. Okay? Congruent triangles, okay? So this speed should equal to this speed should equal to this speed, and then this speed is equal to this speed, okay? So basically, this is Z equals to minus 2 plus I root 3. This should be Z naught equals to minus 8 minus I root 3, okay? So this is my Z naught. That's how I use the geometric approach to determine the location of Z naught. So Z naught equals to minus 8 minus I root 3. See diagram. Okay? And there are only 2 lines. That means you can find some sort of shortcut like what I just did. Okay, find the area of the part of the circle given by the equation, which lies below the real axis. Give your answer in the form P pi plus Q, where PQ are real numbers. So now it is important for us to have the correct diagram. Without contaminating the graph I've drawn, I'm using a highlighter to shade in the region we want to find, okay? So basically, if we take a look at the shape here, this is a segment, okay? Now the segment formula is on the VCAA formula sheet, and now 3 root 3, I suppose this is pi over 3. This angle is also pi over 3. Therefore, we can use the segment formula with radius 2 root 3, okay? So area of segment equals to half. Let's write the formula first. Half r squared, theta take away sine theta. Now, r is 2 root 3. So 2 root 3 squared times 2 pi over 3, subtracting sine 2 pi over 3, okay? Whether or not you use CAS calculator doesn't matter, as long as you calculate the value correctly, okay? So you get 12 over 2, 2 pi over 3, subtracting root 3 over 2, okay? And 6 times 2 pi over 3, subtracting 6 root 3 over 2. So you basically get 4 pi minus 3 root 3. If you wish, you could also write that p equals to 4, q equals to minus 3 root 3, okay? But the answer has to be simplified as 4 pi minus 3 root 3, I suppose. Okay. Now, a second circle is given by absolute z bar plus 2 minus I root 3 equals to 2 root 3. Sketch this circle on the axis provided in part B. You do not need to label the axis intercepts. So what's happening here is you actually subbing in x minus yi plus 2 minus I root 3. Absolute value equals to 2 root 3. You can actually collect the terms like x plus 2 in the bracket minus y plus root 3 bracket I equals to 2 root 3. Now when you expand the square root expression, you should get x plus 2 squared plus y plus root 3 bracket squared equals to 2 root 3. I mean, technically, it's like this. It's bracket negative y plus root 3 bracket squared. But once you square it, you will get a positive term. So you get x plus 2 squared plus y plus root 3 squared equals to 2 root 3 squared, which means we are forming another circle with the same radius, but the location of the center changes to minus 2 root 3. So in fact, this is just, minus 2 root 3 minus 2 root 3. Okay, so basically I should be expecting another circle here, like a minus 2 minus root 3. And it should intersect with the same, the same two intercepts, okay? So I actually reflect the circle about the x-axis or real axis, okay? Basically, this is a linear transformation like z equals to x plus yi assigned or mapped to z bar equals to x minus yi. So think about the coordinate changes. xy is transformed to x minus y. So it's a reflection about the x-axis or about the real axis on the Argand diagram, okay? Right. So basically, that's question 2, and let's have a look at question 3. Question 3 is actually a very nice velocity time graph question. For the first 4 seconds of the motion, the velocity of the lift, so we are talking about the motion of a lift here, as it travels from the ground to the top, the displacement of the lift from the ground floor is measured in meters, and the velocity after traveling for t seconds is measured in meters per second. Here is the velocity function from 0 to 4. And it also tells you 432/3. After the first 4 seconds, the lift travels at a constant velocity of 32/3 meters per second until it slows down to stop at the top floor, having traveled for t seconds. The velocity time graph is symmetrical about t equals to half capital T. So, well, this is a very nice feature. Okay. Because the VT graph is symmetrical, show that the maximum acceleration of the lift during the first 4 seconds occurs when t equals to 2, and that the magnitude of this acceleration is 4 meters per squared second. So if we want to find the maximum acceleration, we need to find the a dt, or use the graph, okay? So v equals to 2t squared minus t cubed over 3 when you expand that. So a equals to dv dt. That equals to 4t minus t squared. Actually, I don't think I need to take the derivative again to get to the dA dt. dA dt has a special name. It's called jerk, okay? If you look at the Wikipedia, it will tell you the dA dt has a name jerk. So I don't need to find this jerk, but I can actually draw a diagram. Because AT graph is a parabola. Use symmetry. Max A occurs when t equals to 2, because this is from 0 to 4 in the middle for a quadratic. And A max equals to 8 minus 4, which is 4. Okay, I mean, you could also say, okay, the A dt equals to 4 minus 2t equals to 0, 2t equals to 4, t equals to 2. Basically the same idea, all right? Yep, that's that. Part A, 2 easy marks. Given that lift travels 96 meters from the ground floor to the top floor, find t. So basically, think about the shape of the graph. This speed, 0 to 4. This speed, something to t. But I remember, this is actually t minus 4, okay? T minus 4. Well, I don't want to play smart here, but actually, if you recognize what's happening here, let me just show you. Because the graph is symmetrical, and this speed is perfectly symmetrical, and this is a cubic function. Point of inflection here, point of inflection here. So basically, if you think this speed of the region as a curvy chunk, you can actually fill up this bit. And then the symmetrical bit, okay, that will trivialize the question, okay? 32 over 3. So basically, you could argue that t minus 4 from here to here, this is the length of the rectangle. We are actually looking at the area of the rectangle times the velocity 32 over 3 equals to 96. And then you just say, okay, t minus 4 divided by 3 equals to 3, because 3 times 32 is 96. So t minus 4 equals to 9, and t equals to 13 seconds. Well, but you have to mention using symmetry and the area of rectangle. Better identify. This is the idea of tessellation. Did I spell this one correctly? Anyway, tessellation. Tessellation. Tessellating an identical part to the blank part and fill up a rectangle. But in my opinion, I think for decent specialist math question, we should use a bit calculus. Well, you could also say from 0 to 4, 2t squared 1 minus t over, is that a 3? Let me have a look. Oh, minus t over 6. Bracket dt. Well, 2 lots of the area plus t minus 8 times the velocity here, 32 over 3, equals to 96. If you solve this equation, I believe it's still t equals to 13, okay? All right, 3 marks, 3 generous marks, I believe. Okay, and find a relation that gives the velocity of the lift v in terms of t for the last 4 seconds of the motion. Well, since we are looking at the, I believe there are multiple different forms of answer, but let's try to make sense of that. Well, firstly, looking at the previous t-value, we can actually make some annotation here and draw ourselves a diagram, okay? Draw ourselves a diagram, do ourselves a favor. Now, this is 13, this is 0, this is 4. So this is 9. Of course, it's not perfectly to the scale. If it was to the scale, it should look like this. Anyway, should look like this. Okay, right. Now, the idea, well, we do want to make sure this part of the graph, let's label this in blue. When I'm trying to transform this blue graph, I want to match the red graph, okay? This looks like a turning point, 4/32/3. This is 0, 0. So for a cubic function, in between, in the middle of the two stationary points, I've got 2,16/3 as the point of inflection. So now, let's say if we can reflect this graph. So basically, if I say let V1t equals to 2t squared, actually I can use the expanded form, even better. 2t squared minus t to the power 3 divided by 3, okay? This green part, is that green? Yep. This green part should be minus v1t, which is minus 2t squared plus t to the power 3/3. And if I want to translate this graph, the green graph to here, well, this is minus v1t plus shifting by, how many units? Actually, from this point to this point, that's 32/3 units. Okay, and finally, I should shift this point to match the red point and shift this point to this red point. That's by 9 units to the right, okay? So basically, reflection in t-axis translate 32/3 up, then translate 9 units to the right, okay? So basically, I'm expecting some sort of a relation like V of 2, let's call this one V of 2 equals to minus V1 of t minus 9 plus 32/3. Therefore, the required relation, well, I didn't simplify this one, but it's still mathematically correct, I believe. Minus 2 bracket t minus 9 squared plus t minus 9 bracket cubed over 3 plus 32/3. Your CAS calculator should be able to simplify this for you, okay, in a nicer form. Also, we should notice one thing here. Because of the transformation, we need to think about the applicable domain. That is, the t-value goes from 9 to 13, but the question didn't specify whether or not we need to specify the domain restriction. So I'll just leave it like that. Okay. All right. Part D. Part D is actually a very interesting case, but it's no longer relevant. Not for 2023 November to 2027. So not for the current study design, because it's involving some sort of a, leaf problem. There is a reaction force. there is a gravitational force for the student, 60G. And if it's going up, acceleration is up, then we have R minus 60G equals to 68. But we know this A acceleration is changing with respect to time, okay? Anyway, let's have a look at this case further. So basically, this A is changing with time. If I want this reaction to be maximized, I need to make sure this is maximized, okay? Because 60G is just a constant. So R max equals to 60 times the positive acceleration, which comes from previous part, 4, plus 60G, which is 60 times 9.8, okay? To get the maximum reaction force, which is 828 newtons, okay? If I want R minimum, notice that acceleration is a vector quantity. It has plus or minus effect, all right? Direction. When this lift is decelerating downwards, okay? That is like on the graph here, okay? Descending at the greatest rate. This is A minimum equals to -4. It's just the opposite way around, okay? Then we should get R minimum equals to 60 times -4 plus 60 times 9.8, okay? So it's 60 times 9.8 minus 4, which gives you 348 newtons, if I calculated correctly. Okay, but anyway, part D is not relevant for the current study design, so just be aware of that. Okay, now question 4, a typical vector calculus problem. So Larry goes for a morning swim in the river that flows into the ocean. He swims once around the closed path. His position vector RLT relative to an origin after t minutes is given by, right, excellent. He leaps again. 50 plus 50 sine t I plus 40 plus 40 cosine tj for t belongs to 0 to 2 pi. Displacement components are measured in meters. So find the Cartesian equation. So x equals to 50 plus 50 sine t. Y equals to 40 plus 40 cosine t. Only one mark, so the correct answer matters, all right? Basically, you just isolate sine t and cosine t term. By looking at x minus 50 divided by 50 equals to sine t. Y minus 40 divided by 40 equals to cosine t. Note that cosine squared t plus sine squared t equals to 1. Therefore, x minus 50 bracket squared divided by 2500 plus y minus 40 squared divided by 1600 equals to 1. You just square these two equations and sub into the trig identity. So this is a Cartesian equation. There is no need to rearrange for y, okay? Cartesian equation can be a relation rather than a function. Okay, the graph of the closed path is shown on the set of axes below. Label Larry's starting point with its coordinate and show the direction in which he swims. So basically, if you chuck in 0, you should be able to get 50 plus 0i and 40 plus 40 cosine 0. That is 40 plus 40. 80j, so 50i plus 80j. 5080 is here, okay? R0 Larry equals to 50i plus 80j, or 50, 80, all right? Now, which direction is Larry going with? I believe we could also try another special value because we just take values from 0 to 2 pi. Just take half pi. If you take half pi, sine t will be 1, okay? Then you will get 100i. Cosine t will be, cosine half pi will be 0. That is 40j only, okay? So 140 RL half pi equals to 100i plus 40j. Apparently, this is going in this direction. Larry is swimming in a clockwise direction, okay? Direction. Put it here. Okay, find the distance Larry travels when he swims once around the closed path. Give your answer in meters correct to 2 decimal places. So basically, you are finding the arc length, okay? So velocity is actually 50 cosine t I minus 40 sine t j. Just differentiate your position vector. So the distance is equal to integral from 0 to 2 pi, because that's the time around one cycle, okay? And take a square root of dx dt square plus dy dt square. So 50 cosine t bracket square plus minus 40 sine t bracket square dt. Don't forget your dt. Using your CAS calculator, you should evaluate that to 283.61667, etc. Correct to 2 decimal places, 283.62 meters. Okay? Right. Very nice arc length problem. And then find Larry's average speed when he swims once around the closed path. Give your answer in meters per minute, correct to 1 decimal place. So remember, your time t is minute, okay, rather than seconds. Now, you are finding the average speed. That is the total distance, 283.61666, etc. Divided by total time is 2 pi. Using your CAS calculator, you should get 45.1389, etc. meters per minute, which is 45.1 meters per minute. Okay? All right. Then express Larry's speed at time t in the form a plus b f of t, where a, b are real numbers. Notice that in the previous part, we actually get the integrand in this form. So look at it before, 50 cosine t squared, that is 2500 cosine squared t. And then the other part must be 40 sine t squared. Okay, that is 1600 sine squared t. But the question wants us to express this thing as a simplified square root trig function. So I suppose we need to do some manipulations here. For example, you may want to do it like this. Split out 2,500 as 900 cosine squared t plus 1600 cosine squared t plus another 1600 sine squared t. So this bit combined to be 1600 only. Cosine squared plus sine squared is just 1. So one possible answer is 900 cosine squared t at 1600. Actually, I should write this term later. So basically, you are expecting this sort of an expression, okay? Alternatively, you could also write 1600 sine squared t as, for example, 2500 sine squared minus 900. That still works. So you can also write this one as let's say 2500 subtract 900 sine squared t, which is also a valid form. And if you really wish, you could also use double angle formula and get some sort of expression like a cosine 2t, etc. Okay, but I think just keep it simple as long as it's correct. Okay, find Larry's maximum speed in meters per minute and give the coordinates of the points. That's an interesting one because we need multiple points. So maximum speed when cosine squared, I'm following the first version, cosine squared t equals to 1. Then it's equal to 1600 plus 900 root 2500, 2500, which is 50 meters per minute. Okay. Now, when would this happen? If cosine squared t equals to 1, that is cosine t equals to 1 or cosine t equals to minus 1. Notice that our domain restriction is 0 to 2 pi, okay, for the time t. So t equals to 0 or t equals to, pi. That should also correspond to t equals to 2 pi, okay? But, well, if t is 0, then, okay, t is 0, that's the beginning. T equals to 2 pi, that's the beginning. 50, 80. T equals to pi, that's halfway, okay? Halfway. Then going back to the original position, not the origin, okay? So the point should be 50, 80, and a 50, 0, if that's the intention of the question. 50, 80, and a 50, 0. Okay, last part. On a particular morning, a dolphin is seen in the river. The position of the dolphin RD of t at a time t minutes is given by RD equals to 120 minus ATI plus 10 plus t squared j relative to the origin. A is a positive real constant and the displacement components are measured in meters. For what values of A will Larry meet the dolphin? Give your answers correct to 2 decimal places. So basically, if they meet each other, that means collision, all right? For collision to happen, equating the I components, we have 120 minus A times T equals to, well, Larry has the position vector, X component, 50 plus 50, sine of T. And for the J component, I suppose 10 plus T squared equals to 40 plus 40 cosine T, okay? And you can use your CAS calculator to solve numerically rather than exactly, okay? So basically, when you solve these two equations, you should get T equals to 2.24469, etc. And A value is 13.7792, etc. Or T equals to 4.45598, etc. And A equals to 26.5632, etc. Correct the 2 decimal places, well, we just need the values of A. So 13.78 or A equals to 26.56. Notice that for the equations, when we solve them simultaneously, we need to look out for the domain because Larry has his trajectory defined over 0 to 2 pi for the parameter, time parameter t, okay? That will help us to reduce the number of solutions obtained, okay? Right. Question 5, another interesting one, actually. All right, so 10 marks, part A and part B. These are all mechanic stuff, good old time, okay? So, not relevant, not relevant, not relevant, not relevant, but actually, part C requires some result from previous part, I suppose. Okay, right. Anyway, so a mass of 2 kilograms sits on a smooth plane inclined at 30 degrees to the horizontal. So the gravitational force is 2g. The normal reaction force, not sure now, but we can figure it out. So let's call this one N, all right? Any other forces? No other forces? Now, we have labeled and shown very clearly the other two forces, okay? So the next job is to find a P. Now, I'm going to use a force triangle. Two G is here, P is here, N is here. This is 30 degrees, definitely. So, P divided by 2G equals to tangent 30 degrees, which is root 3 over 3, or 1 over root 3. So P equals to 2G root 3 over 3. And if you want to substitute G equals to 9.8, that's fine. That should evaluate to 98 root 3 over 15, if I'm not mistaken, because G equals to 9.8. That is also equal to 49 over 5, okay? In newtons. Okay. The magnitude of the tension is in the horizontal spring is changed to T newtons. As a result, the mass accelerates up the inclined plane at G over 4 meters per squared second. So we want to find the T in terms of G. Well, I still draw this force diagram, even though it's not examinable for now. I mean, for historical purposes, we'll never forget. Good old time with mechanics. But now we have more pure math stuff, which might be better. Let's see. So basically, you already have a pair of perpendicular forces. Now, what I'm trying to do is only resolve the normal reaction force N. So this is 30 degrees. So this is N cosine 30 degrees. It's vertical component. This horizontal bit is N sine 30 degrees. I mean, you could also write it as N times cosine 60 degrees. And the other one as N sine 60 degrees. Doesn't really matter as long as you are using the correct values, okay? But now, because N times root 3 over 2, well, hold on a second. We can't resolve the forces in these two directions because the traveling direction is along the plane. So this resolution method is only applicable when we have an object in equilibrium. So we actually need to, do this resolution. Resolve the forces parallel to the plane and perpendicular to the plane. Anyway, still dealing with 60 degrees, 30 degrees whatsoever. So now this speed is T cosine 30 degrees. This speed is T sine 30 degrees. This parallel component is 2G times sine 30 degrees. And the 2G cosine 30 degrees, perpendicular to the plane. And now we should have, okay, the perpendicular part, if we combine the two blue parts, it should equal to n. N equals to t times half plus 2g times root 3 over 2. But that doesn't matter because we are looking at the acceleration direction. The acceleration is up the plane, a equals to g over 4. So we are applying F equals to 2a, which is 2 times g over 4. So the driving force is provided by t cosine 30 degrees minus 2g sine 30 degrees, okay? So now t times root 3 over 2 minus g equals to half g. Half g comes from 2 times g over 4. So basically, t times root 3 over 2 equals to 3g over 2. Okay, so t equals to root 3g. Find t in terms of g. Okay, so that is the answer. Now, what I'm trying to really talk about is RC. Because after traveling 2 meters up the inclined plane, the mass is at the top of the plane. At the instant the mass leaves the inclined plane, the string is released and the mass travels through the air. Look, you need to draw a diagram to physically, describe or visualize what's happening. Initially, the mass sits at the bottom of the plane, okay? So U equals to 0. With my dragging force or the tension force, it has been dragged along this inclined plane, but we don't know the velocity at the end of the plane. So S equals to 0, S equals to 2. The acceleration is g over 4, okay? Once the mass has been dragged on the top of the plane here, then the string is released, and by inertia, the trajectory of the box or the mass will be like a projectile motion, like a parabola, okay? Initially, it follows a 30 degrees angle, okay? Theta equals to 30 degrees. So that is the physical scenario the question wants to describe. That's the intention of the question, I suppose. So first part, you want to show that the speed of the mass at the instant that it leaves the top of the plane is root g. So it's actually talking about the acceleration stage along the smooth inclined plane, okay? So I'm just dropping down U equals to 0, A equals to G over 4. V is unknown, a question mark. The displacement totally 2 meters. So we're using V squared equals to U squared plus 2AS. V squared is unknown, but 0 is known, plus 2 times G over 4 times 2, which equals to G. Because V is greater than 0, upwards, V should be equal to root G, okay? But that is just the V naught of this projectile motion. The second stage is a projectile motion, all right? So then we start to look at, okay, the top of the inclined plane is 1.5 meters vertically above the horizontal ground. I mean, actually, we should relocate this box a bit further up, otherwise it won't match the 1.5. So actually, this bit is 2 meters, okay? So it's 1.5 meters horizontal, vertically above the ground. Now, find the maximum height above the ground in meters reached by the mass as it travels through the air. So actually, we can decompose V naught equals to root G we decompose that into two components, a parallel components. V naught x equals to root g times cosine 30 degrees. So root g times root 3 over 2. And V naught y equals to root g times half, okay? To reach the maximum height. Now, take the point of release with s equals to 0. We are now looking at a vertical projectile motion component, okay? So if we just look at the vertical direction, u equals to half times root g. If there is no air resistance is negligible. Throughout the process, the acceleration should be minus g, okay? A equals to minus g. V equals to naught, momentarily at its maximum height. S is unknown. So we try to figure out this displacement here and then add 1.5 to get the maximum height, okay? So basically we can say, all right, it's still v squared equals to u squared plus 2as. That means 0 equals to g over 4 when you square this with minus 2 times g times s. So therefore your s is actually, let's cancel out the g and we will get a 1/8, okay? But remember, this is not yet the maximum height. We have to consider the altitude we already gained at the point of release. This is 1.5 meters, okay? So the total height relative to the ground is 1/8 plus 1.5, which is 1 5/8 meters. Let's not write it as mixed fraction. This is 1.625 meters, okay? All right, find the speed of the mass in meters per second when it hits the ground. So basically, we can use some sort of vector calculus approach, but remember, if we just think about the velocity when it hits the ground, taking the point of release with s equals to 0. Vertically, we still use the Suva formula, okay? Vertically, we have u equals to half root g, okay? Acceleration is minus g, isn't it? And s now, because if we think about the relative position relative to the start point, we can say this is minus 1.5, okay? So the only thing we don't know is v. We can still use v squared equals to u squared plus 2as. Now, v squared equals to g over 4. And then, let's call this vy, okay? Vy. Minus 3, 1.5 times 2. That's 3 times g, okay? So this should give you, for example, hold on a second. Let me have a closer look. All right, so it doesn't quite work in that way. So I have to carefully look at the signs. Just give me a moment. Okay, back again. So I was just in mental blank. Actually, it works because I forgot when I multiply a negative number with another negative number, this is a plus. So that explains. Yep, that should work. So I should get 13g over 4. But remember, this is just my vertical velocity component, okay? Horizontally, Vx equals to √3/2 times root g. Therefore, my Vx squared equals to 3g/4. Well, that explains everything perfectly, okay? So the speed is equal to square root of Vx squared plus Vy squared. Remember, when it's hitting the ground, this is the Vy component. And horizontally, it remains the same velocity. By the vector triangle, we should be able to get the V hit the ground, okay? So we actually get √13g/4 plus 3g/4. Well, this is 16/4g under the square root. So should be √4g or 2√g meters per second, okay? So that is the answer. Of course, we can use vector calculus method. I'll quickly show you what could happen. Firstly, we need to define position vector. Let's call this one R of t equals to √g times square root of 3/2 times t, comma, and then the vertical initial velocity is √g times half times t minus g/2 times t squared. Okay? All right, and then we can solve when the vertical component is equal to minus 1.5. If we take the upwards as positive direction for t, given that g is greater than 0. So you can actually get 2 times, but definitely we take the positive one, okay? And then we take the derivative of the position vector to get the velocity. All right, so you should get the velocity like this. Notice that the vertical component is negative, okay? And then we take the magnitude of this velocity when the box or the object is hitting the ground. Notice that the CAS calculator needs you to specify g is greater than 0. So the answer is 2√g, which is consistent with our previous method, okay? Right, so that is question 5, which is a very interesting and very flexible kinematics and a vector calculus question. Projectile motion, let's have a look at the last one. Okay, all in all, the lucky last, probability and statistics. The manufacturer produces bottles of mineral water. The volume of mineral water in each bottle is normally distributed with a claimed population mean of 750 mils. Population mean is 750 mils, and the known standard deviation is 2 mils. So mu naught is 750, sigma is 2. Quality control inspectors take random samples of 10 bottles, so n equals to 10. For a sample of 10 bottles, state the mean of the sampling proportions. So we are looking at expected value of x bar, which is still the mu naught, 750, expected value. And show that the standard deviation of the sampling distribution is √10/5. So standard deviation of x bar is sigma divided by √n. Population standard deviation divided by √n. Root number of trials or sample size. So we have 2 over square root of 10. But we need to show some calculations. That is 2 times √10 divided by 10. That is √10 divided by 5, okay? All right. Yep, we assume that the mean volume of the mineral water in all bottles produced is 750 mL as claimed. The inspectors will query the manufacturer's claim that the mean volume of mineral water in all bottles produced is 750 mL if the mean volume in 10 randomly selected bottles is less than 749. So what is the probability that the inspectors will query the manufacturer's claim? Give your answer correct to 4 decimal places. Assume that the mean volume is still 750. So X bar is a normal distribution, 750. Standard deviation is root 10 over 5. The variance is this squared. So we actually want X bar. The mean volume, the average volume, is less than 749, okay? You can use your CAS calculator and get the answer. Like, you can use norm CDF minus infinity, 749, 750, and root 10 divided by 5, okay? So the answer is 0.0569, okay? Correct to 4 decimal places. What is the probability that the inspectors will not query the manufacturer's claim? Not query means the X bar is greater than or equal to 749. But actually, the mean is now changed to 749.5. So now we say X bar 2 is another normal distribution, 749.5. But the standard deviation should remain the same. Okay. Now we'd like to see X bar 2 greater than or equal to 749. Given that mu is now 749.5. So you can also use your norm CDF, but be aware, okay, how you should fill in your entries. 749 to infinity. Now it's not 750, it's 749.5, root 10 over 5, okay? So this new probability should be 0.7854024. Correct to 4 decimal places, that's 0.7854, okay? All right. The graph shown below represents the sampling distribution of the mean for samples of 10 bottles, where the population mean is 750 and the standard deviation is 2 mL. Okay, now on the axis below for the sample of 10 bottles, sketch the graph of sampling distribution if the population mean is in fact 749.5 and the standard deviation is 2. So it's talking about X bar 2 now. Okay, the standard deviation remains the same, so I expect the same shape of the distribution, but different center, different location. What I'm doing is I will translate this graph by half unit to the right. You know what I'm saying? Okay, so basically 749.5. So this is X bar 2, normal distribution, 749.5, root 10 over 5 whole thing squared. And then on the axis below, shade the area that represents the probability found in part B2. So we want the probability of under X bar 2 greater than 749. All right. Let's rub out this bit dash lines. 749 is under the new graph. So from here, let me just use a highlighter. As you can see, the shaded part under the new graph is definitely beyond greater than 0.5, which is reasonable and consistent with our calculation, okay? So this is a great place to confirm, okay, we've obtained a reasonable answer in part B2, okay? So that is the required shaded region. Okay, the inspectors decide to apply one-sided statistical test at a 5% level of significance to determine whether to reject or not reject the manufacturer's claim mean of 750 mils. So the null hypothesis is mu still remains 750. The alternative hypothesis is mu less than the claimed value, okay? Not less than 749. We still compare everything against the original population mean, okay? Right. In applying the statistical test, the inspectors find that the mean volume of mineral water in a random sample of 10 is 748.9. Assume that the mean for the population is 750 and the standard deviation is 2 mils. So find the p-value for the test corrected 2 decimal places. Well, the p-value is simply probability x bar less than or equal to 748.9, given that the mu value is 750, okay? Right, so we are looking at the norm CDF again, but this time it is very simple. So basically you will just get a 0.040995, etc. And it's rounded to 0.04, corrected 2 decimal places, okay? Okay, now, the inspectors decide to apply a one-sided statistical test at the 5% level of significance. So the level of significance is stated here. So the p-value equals to 0.040995 is less than 0.05. Therefore, we reject H naught. So the mean is less than 750 mils, okay? So basically that's something we are looking at. But also we will have this sort of a phrase here. The inspectors will query the manufacturer's claim that the mean volume of mineral water in all bottles produced, blah, 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 if it's less than 749. So actually, well, you could also refer to this value, but remember, we are actually referring to the p-value rather than the x bar value, okay? So I think we just follow the normal procedure, find the p-value and compare this p-value with our level of significance. Okay, last one. For a sample of 10 bottles, find the smallest sample mean above which the inspectors would not reject the claim of 750 mils at the 5% level of significance. Give your answer in mils. Corrected 2 decimal places. Well, this is an inverse norm problem. So this is x bar, 750 here. Let's find the critical value, 0.05, okay? So probability x bar greater than or equal to C star equals to 0.95 for not rejecting. So we also have x bar less than or equal to C star equals to 0.05 with mean value 750 and a sigma x bar equals to root 10 over 5. So C star is actually 748.9597. Corrected 2 decimal places, C star is 748.96. Well, we do follow the normal rounding because if we round it down, it will be in the black region. In the black region, our action is reject H naught. In the white region, we do not reject the null hypothesis. That's why we can naturally round it up and give it to 2 decimal places. Okay. Right. Hopefully you will find this video helpful in some way, and I probably will do some videos in future, maybe after 2 or 3 months, after I finish my parental leave and get resumed back to work. Good luck with your exam preparation, and I will see you in the future.